All right, this is just going to go over the review assignment for the first half of the chapter. So these first examples, really the directions just asked you for end behavior. So this one, our leading term is positive 1x to the 8th. If it's positive, the right side of the graph finishes pointing upward. And if it's an even function, the left side is also pointing upward. So we could write it with words as up and up, or we can draw the arrows. Here we have a negative, so the graph finishes pointing downward. And it's even, so that means it started pointing the same way. And that makes the end behavior down and down. Here we have positive, so finishes pointing up. And it's odd, so it must have started opposite. So we can write down and up. And that is the end of the first three examples. Now the next set we didn't go over. I'm just going to give you a quick mini lesson. It's not absolutely critical, but it can't hurt. Basically, I made up a linear function and I filled out a table of values. Since it's a linear function, something's going to happen. So this column has to be consecutive values, okay? And here are my outputs, my y values that I get from plugging those in for x, since some people seem to struggle plugging and making a table of values, right? Now, what you do is you check the difference between consecutive values. So how far apart are -4 and -2? 2. How far is -2 from 0? 2. How far is 0 from 2? 2. 2 from 4, and 4 from 6. They all match. It took one step, all right? So one row for a match. So it's going to be a first degree. So that means the degree is 1, first degree. And what kind of equation is a first degree equation? A linear. Obviously, you normally wouldn't see the equation, so that's why I made up examples over here. Now this one's quadratic, which is second degree, so it's probably going to take us 2 steps. So what does that mean? How far is 5 from 2? 3. How far is 2 from 1? 1. How far is 1 from 2? 1. How far is 2 from 5? And 5 from 10 even. Do they match? No. Now, how far is 3 from 1? How far is 1 from 1? How far is 1 from 3? And how far is 3 from 5? Took 2 steps. So it's 2 rows or steps or whatever you want to call it, column, for a match. So that means second degree. All right, and that would be quadratic. Make sure you know these names really well. So let's go back over here. How far is 159 from 29? Well, take off the 9s, take off the 20s. You're left with 130. How far is 29 from -1? 30. How far is -1 from -3? 2. -3 to -1? 2. 30. 130. So definitely not first degree. How far are those? Definitely not quadratic. How far are these? 70 to 100, or 30 to 170, so it's 72. 28. 28. 72. All right, how far apart are these now? A little harder, a little bit more adding. How far is 30 to 70? That's 40. 2 more up, 2 more down. So that's going to be 44. Can I add? 70, 30, it's 40. 2 more, 44. Yeah. 28 to 28. Well, 0. 28 to 72. 44. First degree, second degree, third degree, fourth degree. All right, we're here. How far is 44 from 0? And how far is 0 from 44? Now we match 5. So it took 5 to go out there. So this is a quintic. I don't know how many terms are in it. I just know it's quintic. All right? Next. Solve by factoring. First and foremost, get it equal to 0. Factor. Take out the greatest common factor. What multiplies to give you 36 and adds or subtracts to give you 5? 1 and 36? No. 2 and 18? 3 and 12? 4 and 9? Not done. Solve by factoring. We're using zero product property. That's done. You can write the answers like this if you want. -4, 0, 9. And you're good. Next. Gotta recognize it. X is 2/3. That's my one real solution. Now here, here's our shortcut. Two times 9 is 18. Can reduce 6 from everyone, so final. I'll get -1 plus or minus I root 3 all over 3. 2 imaginary and 1 real solution. I can leave it like that. I can write it like this if you really want. We can do or I could have, that's a 1. Or I could have written them separately with a comma, one with the plus and one with the minus. This one is quadratic in style. What multiplies to give you 64, but adds to give you 20. Could it be 1 and 64, 2 and 32, 4 and 16, probably. Well, that's convenient. All good. Here, another example with the sum of 2 cubes. There we go, 3 answers. I'm going to write like this, -5, 5 plus minus, 5i, root 3, all over 2. Alright. Remainder theorem, find p of 4. I could either fill 4 in, or I could use remainder theorem. Do you want to show what it was? Since you opened the book to do the homework, you should flip back, or open your notes. 2, there's no cubed. Placeholder, -3, 4, -1, 2, that gives us 29. 30 times 4 would be 120, so 116. 120 times 4, well 12 times 4, 48. That's the remainder, so if you're not sure if it's right, you could always check it in a calculator. We're good. Alright, this one, they gave us volume. They want to know which of these could be the dimensions. Alright, since volume is length times width times height, and if that's volume, that means the length, the width, or the height have to divide into it evenly. So this is just a division question. Okay, so we just need to check, will division work? Will I have a remainder or won't I have a remainder? You can do synthetic for these. You have to do long for that one. So if I want to do this one, I'm going to try 1. because you set that equal to 0. That's how you get the number for that. So this is a dimension. Now, 2 to 6, 12 to 16, that's 1 to 3, that's not 1 to 3. I could try dividing here. I could also see if negative 2 goes into this. If it goes into this, then it goes into this, right? So I'm going to put negative 2 here, so I don't have to rewrite anything. Alright, because of that right there. Now here, I want to divide this in. I'm going to use long division, but I can use this. That was to the 4th, so that's to the 3rd. That'll go on the outside. 2x plus 8, that's my divisor. And then I'm using this. 2x to the 3rd, 6x squared, minus 12x, minus 16. Now it's getting a little bit crowded, so I'm just going to change my pen color for a little bit, just so you can separate the work. What's 2x cubed divided by 2x? X squared, multiply it right here. 2x cubed plus 8x squared, parentheses, minus sign, underline, cancel. That's going to be a negative 2x squared minus 12x. Negative 2x squared divided by 2x is negative x times this. Negative 4x divided by 2x is negative 2. I get negative 4x minus 16. We're done. Remainder is 0. Put these in standard form and classify. It's pretty easy. Alright, last two. What does this look like? Well, we already talked about a regular x cubed. Looks like this, right? The other point passes through is 2, 8, and negative 2, negative 8. So it looks like this. The negative 5, well, the negative does a vertical reflection, and the 5 is a vertical stretch. Don't really have the most room here, but I guess I could use my imagination a bit. So it flips and stretches. So 2, 3, 4, 5. That stays the same. Flips. That's 1, 2, 3, 4, 5. Did you have to actually fully graph? No, but I'm just kind of drawing a little bit. So that the shape is cubic, decreasing the whole time. If I want to give some more details, you'd say it's decreasing because we go from left to right. Here, I know it's hard to see, but we can say it's concave up from negative infinity until 0, and it's concave down from 0 until infinity, and there are no extrema, which is a fancy word for maximums or minimums, and no turning points. They never change directions. A turning point is like this. Turned around, max or min. Alright, we don't have any of those. So, none. Now here. This one's a little different. You can't just graph it by factoring. If I had to guess, I would say we could get a little bit more inventive. We can make a table of values, but let's do a calculator for this one. So going over how to graph it with the calculator a little bit. So, turning this on, y equals, clearing out what is in there, Now, before I go to graph, for the millionth time, let's go zoom, and let's go number 6, standard. Now, maybe it turns, maybe it doesn't. How can we tell? Well, we could zoom in. I would say let's just use the zoom in button. So I'm going to go to number 2, and you hit enter again. Doesn't really look like anything was changing direction over there. If you weren't sure, okay, I mean, how can I be sure? Does it go down a little and then go back up? I guess we could zoom one more time. So the cursor, I'm going to move closer to that middle area there. No, it definitely doesn't look like it ever dips down. Now, if you wanted to confirm, you go second, calculate. Let's say I wanted to look for a minimum. Okay, go all the way to the left. Now, pay attention to what you put for your left bound. Let's do a familiar looking number, 611. Enter, 611, 1.41, negative, both of them. And I go over it a lot. Now, what it's doing for me, it's going to tell me if it ever dipped to a low, a minimum, somewhere in between there. Guess, I don't know, going in the middle. No, it gave that leftmost point. That means that the left point is my minimum. So that means it doesn't dip down ever in between here. So there are no turning points. All right? It's always increasing. And that's really good enough for right now. You could say the y-intercept is 0, -1. It's always that last number here. Crosses through the origin on that other one, right? There's no plus or a number at the end. And that's everything. All right? Enjoy.